Hello students. So let's try to solve one more problem from CSIR-NET 2023. And this exam was held on 8 June. So this is a very simple problem, a straightforward problem. And this problem is from Perturbation. The question ID is 36. You can have 705036. So this question is from Perturbation. So it is given a particle is trapped into one-dimensional box and its boundary of box is minus L by 2 to plus L by 2, and this is infinite box, which is perturbed by perturbation, that is epsilon cos pi x by L. So the perturbation is a function of cos. So you can have this type of function. So we have to calculate what will be change in energy up to order of epsilon. That means we have to calculate actually first order energy correction. So we all know that for the ground state, obviously, so we have to calculate first order energy correction in ground state. So what will be first order energy correction in ground state? E1 is equal to pi 1 HP pi 1. So we have to just calculate this particular value. So we have to just identify what is my phi 1. So we have to see that this potential is symmetric potential. So we have to be very much careful. The phi 1 will be root under 2 by L, because this is from minus L by 2 to plus L by 2. The width of box is L. So this value is root upon 2 upon L. But this value is cos pi x upon L. So we have to know that if my wave function is symmetric, that is for n is equal to 1, n is equal to 3, we have cos function, and for n is equal to 2, 4, 6, we have sine function, because parity have to be conserved. So this thing is very important into this problem. Lot of people have done this thing, some blunder, that they are taking ground state as sine function. Sine function will not a ground state into this particular potential. You have to keep in mind that cos function is the main ground state function, and that value is between minus L by 2 to plus L by 2. Otherwise, this value is 0. And obviously, we have this particular perturbation, that is epsilon cos pi x by L. So when we will go for this particular thing, then we have integration 2 by L, and I can take epsilon outside, and this value is minus L by 2 to plus L by 2. So what is phi 1 star? So 2 by L is due to this integration constant, or you can write something else, something like this. This is 2 by L cos pi x by L. HP is equal to epsilon cos pi x by L. And again, phi 1 is equal to root 2 by L cos pi x by L dx. So I can take all these things outside this integration, and this integration is 2 by L epsilon integration minus L by 2 to plus L by 2, and we have to go for cos cube pi x by L dx. So the whole challenge is, if you are choosing the first thing, you have to very much conscious that you have to choose this wave function as your ground state. And after then, the second challenge is that you have to do this integration very carefully. Obviously, this integration is even integral, so I can change it as 2 by L epsilon 2 0 to L, and this value is equal to cos cube pi x by L dx. So there are n number of ways, L by 2 there is actually. So there is n number of ways that you can calculate this particular integration. You can go for sine 3x formula. You can go for another way, but I have difficulty to remember the formula. So I will change this integration in some different way. So let's try to go for this one. So I am just doing this calculation here. So what I am going to do, I will just change this integration. So we have 4 upon L epsilon, and I can just go for this integration is 0 to L by 2. I will take cos pi x by L as common, and then I can write all the thing, and rest cos square pi x by L, I will write 1 minus sine square pi x by L dx. So this integration can be divided into two parts. So I can use this space also. So I am just doing this integration, that is 4 upon L epsilon. The first integration is 0 to L by 2 cos pi x by L dx. The second integral is very interesting, that is 0 to L by 2, and we have sine square pi x by L and cos pi x by L dx. So now this integration is very simple for us. Why? Because this integration is straightforward. That value is 1 we will get. And this integration is very nice, that we can put sine pi x by L is equal to t, then cos pi x by L dx is equal to dt. So this is something t square dt. And when sine pi x by L is equal to t, then this value is equal to 0 to 1. So this integration is very simple and very straightforward right now. So you can do this integration smartly. So when you are doing this one, so we will get that 4 upon L epsilon. This value is equal to obviously sine pi by 2. So you can just do this integration. The integration of cos is sine, or you can write sine pi by 2 and pi by L is also there. Minus the another one we can just go for. This value is sine cube pi by 2 upon 3 pi by L. So if you will do the integration smartly, you can use this particular fact. And then we can easily calculate the final term. So this is very simple. So this L will cancel out. So we have 4 epsilon is there, and we have, and pi will outside. So we have 1 minus 1 upon 3, and that value is equal to 4 epsilon by 3 pi into 3 minus 1 is 2. So that value is equal to 8 epsilon upon 3 pi. So this is option number 3. So if I am not doing any wrong calculation, then I think the option number 3 is the correct. So if you have any suggestion, any advice, any better method to solve this one, please suggest me. And I really appreciate when you remember this cos cube formula, but I have my own constraint that I have difficulty to remember the formula. So I break into this part. So this is fundamental question, straightforward question. But yes, you have to be a little bit conscious to doing integration and choosing the wave function. Thank you.